So this class opener, all we're doing is distributing, and it's as easy as taking the outside value of the parentheses and drawing arrows. 7 times x, 7x. 7 times 7, 49. Let's move on to question number 2. That's all there is to do on number 1. You can't combine 7x plus 49 because they're not alike. So let's move on to number 2. Once again, distributive property. Take that 5q and multiply it by 2. So what's 5q times 2? Anybody? You're welcome. 10q. And then 5q times negative 5q. Okay, so you go 5 times 5, that's negative 25. And then the q times q, that's 25q squared. And that is your final answer for number 2. Again, you cannot combine the 10q with the minus 25q. I guess there's one more thing you could do. You could put it in standard form from highest exponent. So that'd be a negative 25q squared with a positive 10q at the very end. So I guess that one's the better answer in blue because it's in standard form. Either one's correct though. Number 3, we have 2 variables here. Let's distribute. So I want to distribute that 8a times x. You simply just write it together because 8a really means 8 times a. And then put the x right there, that means times x. So 8a times x is simply 8ax. And then 8a times negative 7, we're going to multiply 8 times negative 7 and get negative 56. And of course the a, we just slap it on right there to the answer. So this is it, your final answer, because you cannot combine the 8 with the 56 because the first term is an ax term and the second term is just an a term. Moving on, number 4. We have a trinomial on the inside and an x, a variable x on the outside. Let's distribute it to each one. X times 1 is x. X times xy. Of course, I could do x times x. What's x times x? X squared. Bring down the y. And then the last one, x times x squared, y squared. What do I get? What's x times x squared? X cubed. And then the y squared is still there. Let's not forget about our signs. I'm sorry, I forgot to put the plus there and the plus there. So there's our answer for number 4. Let's move on to number 5. Again, we have a monomial on the outside, 4x squared. And I'm going to distribute that 4x squared to each of the 3 terms on the inside of the parentheses. So 4x squared times 3x to the 5th. Let's do the coefficients first. What's 4 times 3? 12. What's x to the 2nd times x to the 5th? X to the 7th, right? You add the exponents when you're multiplying. Okay, so we've distributed it to the first term. Let's go to the second term. That's just the number negative 2. So 4 times negative 2, that's negative 8. And we're just going to put the x squared right there because there is no other x to multiply it with. And then the last term, 4x squared times positive, you could put a 1 right there if you want, positive 1x to the 3rd. Well, 4 times positive 1, that's positive 4. And x squared times x to the 3rd is? Come on, people. X squared times x to the 5th. Thank you very much. And that's our final answer there. Any questions? We should all know how to do this, right? Simply distributive property. Now, that's an essential skill for what we're going to be doing right now. On this first video, we're going to be learning how to factor out the GCF. So what is factoring? It's simply doing distributive property backwards. It's like having the answer and trying to find the question. Now, there are many different forms of factoring. There's factoring out the GCF. There's factoring by grouping. There's factoring quadratic trinomials, or where we could apply a shortcut. But right now, we're just going to do basic factoring. We're going to learn how to pull out the GCF. So what does GCF actually mean? Anybody? So it does mean greatest common factor, the GCF. Okay, so what we want to do is look at a polynomial, and it says right here, we want to pull out any common multiple in all of the terms of the polynomial. Okay, I underlined and bolded the word all. Okay, because you have to be able to pull it out of every single term of the polynomial in order for you to factor out the GCF. So here are 4 examples. I'm going to do it. I want you guys to follow along. Number 1, I have a binomial 8x minus 12. So I need to ask myself, what's in common in each term? Is there an x in both terms? No. There's an 8 and a 12. So I could do the multiple. What's in common in both terms right there? The multiple of 4 is the best one. I mean, if you're saying 2, that's a common factor. You could factor out a 2. But 4 is the greatest common factor. So let's pull out that 4. So this is what we want to do, guys. Let's write down a 4 out here and parentheses in that same position as the 8x and the 12, okay? So if I do pull out a 4 from this first term, what would be left? In other words, 4 times what gets me back to the 8x? 2x, right? So if I pull out a 4, I will have a 2x left over on the inside. Okay, if I pull out a 4 from the 12, what will I have right here? Minus what? Minus 3. In other words, 4 times what gets us back to the minus 12? Like you guys just said, a minus 3. And that is factoring. That's it. Okay? Like I said, factoring is a reverse distributive property. It's like doing it backwards. So if I were to give you this question right here, like if I were to block this out, and I give you this question right here, and I told you, go ahead and distribute, what answer are you going to get? You're going to get that answer up there, 8x minus 12. Make sense? Okay, so factoring is doing distributive property backwards. So if you ever are wondering, did I factor this correctly? Well, you could check it by distributing 4 times 2x. Does it give me 8x? Yes, it does. 4 times minus 3, does it give me minus 12? Yes, it does. So you're absolutely positive you've double checked that you factored it. Okay, let's move on. Over here we have number 2. It's a lot more complicated. It's a trinomial. I need to ask myself, what's in common? Well, I see a 3 here, a 6 here, maybe a 3, but there's no coefficient on the first one. So there is no multiple, like no number that I could pull out. But there are letters that are in common in all 3 terms. We have 1, 2, 3 terms. What letters in common? X and Y? Just Y, right? So there's an X here, but no X over here. So I can't pull out an X. Because remember, on our notes it says in all. It has to be all the terms that you're able to pull them out of. So on number 2, there are no X's in common. You guys just said there's Y's in common. But remember, we want the greatest common factor. So what's the maximum amount of Y's that I could actually pull out of all 3 terms? The maximum amount of Y's. What do you guys say? Give me a guess. It's okay if you get it wrong. What's the maximum amount of Y's that I could pull out of all of them? 2 is the correct answer. If you're thinking 7, oh, I could pull out 7 Y's. Well, you could pull out 7 Y's from here, but right here there's only 5. You can't pull out 7. And right here you can't pull out 7. There's only 2. So the greatest amount of Y's that you could pull out is 2. Okay, so it's kind of like you're going for the smallest exponent term, the y squared. So that y squared is the GCF. And then you do parentheses right below it. So if I were to pull out a y squared from this first y to the 5th, how many y's would I have left? What would my first term actually be? xy to the 3rd. Okay? Again, the logic is y squared, that's your GCF. Y squared times what will get you a xy to the 5th? Well, that would be xy to the 3rd, because if you do multiply y squared times xy to the 3rd, that would get you xy to the 5th. Okay, so how about over here? Y squared times what will get you a negative 6xy to the 7th? Y squared times what will get you a negative 6xy to the 7th? Obviously, it has to be a negative. I need a 6, guys. How am I going to magically end up with a 6 up here? I need to put a 6 down here. Yeah. Make sense? So I will have a 6. I will have an x. But what about the y's? How many y's do I need to have right here in order for it to become 7? 5, that's right. Okay, so I'm going to put a 5 right here. Are you guys with me? Okay, now for the last term. Y squared times what will get me a positive 3y to the 2nd? Okay, plus 3. Because y squared times 3, y squared times 3 will get us that 3y to the 2nd. And that's what factoring is. It's a reverse distributive property. Okay, let's continue. And like I said, you guys are just following along. I'm doing these. Number 3, we have 3 terms. Do we have any numbers, any multiples that are in common? Could I pull out an 8 from all the terms? I cannot pull out an 8. What could I pull out? Could I pull out a 2? Yes, but is that the greatest common factor? Or is there a bigger number that I could pull out from each of these terms? 4 is the greatest, okay? So I could pull out the multiple of 4, but there's also something else in common besides the multiple of 4. X's, that's right. Now, what is the greatest amount of X's that I could pull out? Okay, so my GCF is not just the number 4, but it's actually 4x squared, okay? And then you put the parentheses here. And now we need to fill in what belongs inside of the parentheses. So I'm going to ask myself, what 4x squared times what will give me this first term? 2x, right? 2x, because 4x squared times 2x will give me the 8x to the third. Now how about this? 4x squared times what in the middle will give me a negative 16x to the fifth. Negative 4, okay, that gives us a 16 so far. X to the third, right? Because x squared times x to the third is x to the fifth. You add them. You guys following me? Okay. Now the last term, 4x squared times what will get us a 12x squared? Positive 3. If I put an x right here, wouldn't that be 4x squared times 3x? Wouldn't that be 12x to the third? And we don't want a third right there, right? So just the number 3, right? Okay, so let's erase that x, just the number 3. Okay, so like I've mentioned before, it's all doing distributive property backwards. So 4x squared times this will get us this first term. 4x squared times that will get us this second term. 4x squared times that will get us this third term. Okay, so you identify the GCF, you identify what's in common in all terms, then you pull that out and figure out what's left over on the inside. So what's in common in all 3 terms right here? Do I have a 2 in each of the numbers? A multiple of 2? No. Do I have x's in each of the terms? No. So is there a GCF? No, there is no GCF. You can't pull out anything. So what do we say? Different books say different things. One option is prime, okay? But I prefer to just say not factorable. Now, what does that mean? That means that you're not able to factor it, okay? You're not able to factor it. I prefer not factorable. But just to let you know, some books just say prime. That means that you can't factor it, okay? I say not factorable. Okay, so now that you've seen me explain those, how about you guys, you and a partner, try to do the following. 1, 2, 3, 4, 5. Go for it. So hopefully you guys already finished at least some of these. Number 1, what's in common in both terms? What could I pull out?
7.
A 7. So this is what we should all do, guys. Put a 7 on the outside, put parentheses, and then figure out what's going to be on the inside, what's left over on the inside. Remember, it's like doing distributive property backwards. Okay, so 7 times what will give me a 7x. And if you're not too sure, you could just guess, right? X, okay? So 7 times x, that will actually give us a 7x. Now, how about this? 7 times what will give us a positive 49? A positive 7. And that's it. We're done. We factored, okay? If you guys are thinking, man, that was easy, it is. This is not challenging. The next half of this class is where it gets more challenging. Right here, we're just getting our feet wet. Number 2, what's in common in both terms? Okay, so I saw one student say just 5. Okay, that's fine. Or another student just said Q. But the greatest common factor that you could pull out of all terms at the same time is both the 5 and the Q. So 5Q. Okay, then write your parentheses and let's figure out what's left over on the inside. So 5Q times what will get us this first term 10Q?
10Q?
You're welcome. Yes. just 2. No q because that would give you a q squared. So yeah, 5q times 2 will get you that 10q. And then over here, 5q times what will get you a negative 25q. A negative 5q. So let's go negative 5q. And that's it. You factored. We're done. Now let's say you weren't too sure about that. What could you do to double check? You could actually distribute and see if it does give you the above answer, which it does. Let's move on to number 3. Whoa. 3's right here. Sorry, I'm all over the place. Okay, so number 3, what's in common in both terms? I have an 8 here, the coefficient 8 and the coefficient 56. 8, right? So we could actually pull out an 8, but is that the greatest, or is there something else that I could pull out with the 8? There's also an A and an A, so I'm going to pull out an 8A. That is my GCF, okay? So if I pull out the 8A, what will I have left on the inside? X. Just X? Minus 8 times what gives you 56? 7. And that's it. We're done. Let's move on to number 4. So what could I pull out of there? I have 3 terms, but notice I don't have any coefficients. I don't have any numbers out here in the front. So I need to think about pulling out letters. What's the maximum amount of letters that I could pull out of all of the terms at the same time? 1 what? 1x, right? I could pull out an x. So I'm going to pull out the x. I'm going to put the x on the outside. I'm going to put parentheses here. Now let's write what would be left over on the inside. So again, x times what gives us this first x? X times 1, right? And then how about x times what? What's going to be right here in the middle will give us a positive x squared y. X times what? Yeah, that's right, xy. So positive xy. You guys agree, right? X times x will give us the x squared and the y's right there. How about this last term that's x to the third y squared? So x times what will give us x to the third y squared? Positive x squared y squared. It looks like you guys are getting the hang of this, right? Let's go for the last one. Number 5. I have 3 terms. I do have coefficients. I do have variables. So what's my GCF? 4x, just 4x, or is there something? 4x squared, right? You want to pull out the greatest common factor. Now, let's say this, guys. Let's say you didn't figure out the greatest common factor. Let's say you just pulled out a 4. So what would you have left? Oh, you'd have a 3x to the 7th. You'd have a minus 2. Don't write this down, guys. Just watch. 2x squared. And you'd have a plus x to the 5th. Now, if you look at the inside, when you don't pull out the GCF and you look at the inside, you could still pull out something else, right? What could you pull out from the inside? X's, right? How many X's? 2. So it's kind of a waste of time to not pull out your GCF, right? So let me go back. Let me erase this right here. And let's pull out the GCF, which is 4x squared. So if we pull out that 4x squared times what will give us 12x to the 7th? 3x to the 5th, okay? And then how about 4x squared times what will give us that negative 8x squared? Negative 2, that's right. And how about the last one? 4x squared times what will get us that 4x to the 5th? Positive x to the 3rd. Perfect. Now, if we continue reading on this paper, it says, as you can see, each of these corresponds to the class opener questions to reinforce that factoring is simply doing distributive property backwards. It's like having the answer and finding the question. So if you compare what we just did right here compared to the class opener up here, we see that it's the same problems, right? It's just that down there I asked you to factor 7x plus 49, and when you factor it, you end up with the above distributive property problem. Cool? Now, it does say right here on this video, it says right here, stop here and do 8.5 WSPM numbers 1 through 12. Okay, so let's check that out. Okay guys, so here's 8.5 WSPM, and on that first part of the notes, I said now you'll be able to do 1 through 12, okay? So on this first video, you should be able to do all of these 1 through 12. And as you could see, number 1, factor 7x plus 49, we did that on our notes, right? So you should be able to do all these factoring out the GCF, because 1 through 12 is all about factoring the GCF. You want to pull out the greatest common factor in each of those, okay? So I would try to do some of these. Now 13 you can't do yet. Let's watch, or let's create video number 2, and after you watch video number 2, you'll be able to do 13 through 18. You see 13 through 18, they're a little weird, but I want to pick that up on the next video.